potential difference between ground and grounded conductors can stem from several possible causes. Firstly, a poor neutral connection, whether loose or corroded, either at the subpanel or the main panel, can cause a voltage drop. This voltage drop results in a potential difference between the neutral and the ground. Secondly, an open ground path along the neutral wire or the ground rod can prevent the current from flowing through the ground. This prevention causes a voltage build-up on the neutral. Thirdly, a ground loop can occur when multiple grounding paths exist. This creates a circular current flow and consequently potential differences between grounded conductors. Fourthly, induced voltage can arise from magnetic fields. Magnetic fields from nearby power lines or transformers can induce voltage on the neutral wire, leading to a potential difference. Fifthly, faulty equipment like a defective transformer or motor can create a voltage leak from the windings to the ground. To effectively troubleshoot this issue, several steps can be taken. Firstly, check all neutral connections. This involves tightening all neutral connections at both the subpanel and the main panel. Replace any loose or damaged terminals. Secondly, inspect the ground path. Verify the continuity of the ground wire. The verification should be from the subpanel to the main panel and to the ground rod. Repair any breaks or replace any damaged wire. Thirdly, eliminate ground loops. Disconnect all other ground connections except the grounding wire from the subpanel and then test for the potential difference again. Fourthly, check for induced voltage. Move the subpanel away from potential sources of magnetic interference such as power lines and test again. Fifthly, isolate any faulty equipment. Disconnect each load one at a time and test for the potential difference. If it disappears when a specific load is disconnected, that load or its associated equipment may be faulty. It is important to remember to consult with a licensed electrician for a professional assessment and any necessary repairs. Ensure that the subpanel is properly bonded to the ground rod or other grounding means. Inspect the subpanel for any signs of damage or corrosion. When a potential difference exists between the ground and grounded conductors, it indicates that there is an unintended voltage present in the grounding system. This voltage, though seemingly small, can be an indicator of underlying issues that can pose electrical hazards or equipment malfunctions. One of the primary reasons for this potential difference is an imbalance in the neutral current. In a properly functioning electrical system, the neutral wire should carry very little current back to the source. However, if there are unbalanced loads, loose connections, or neutral faults, the neutral wire can carry significant current. As this current flows through the impedance of the neutral conductor, it creates a voltage drop, leading to a potential difference between the neutral and the ground. Another contributing factor can be ground loops. Ground loops occur when there are multiple paths for ground current to flow. These multiple paths can create circulating currents, which in turn induce voltage drops in the grounding system, resulting in a potential difference between the ground and grounded conductors. In addition, electromagnetic interference, EMI, from nearby equipment or power lines can also induce voltage on the grounding system, leading to a potential difference. When dealing with potential differences between ground and grounded conductors, it's crucial to follow a systematic troubleshooting approach to identify and rectify the root cause of the problem. The initial step in troubleshooting is to visually inspect all connections in the electrical system. Pay close attention to the neutral connections at the subpanel, main panel, and any intermediate junction boxes. Look for signs of corrosion, loose terminals, or damaged wiring. Tighten any loose connections and replace any damaged components. The second step is to verify the integrity of the grounding system. Use a multimeter to measure the resistance between the grounding conductor at the subpanel and the grounding electrode system. The resistance should be as low as possible, ideally less than 1 ohm. If the resistance is higher than expected, inspect the grounding electrode connections and the grounding conductors for any signs of corrosion or damage. Repair or replace any faulty components. The third step is to check for unbalanced loads. Use a clamp meter to measure the current flowing through each phase conductor and the neutral conductor at the subpanel. If the neutral current is significantly higher than expected, it indicates an imbalance in the loads. Redistribute the loads to balance the current flow and reduce the neutral current. The fourth step is to isolate potential sources of EMI. Move sensitive equipment away from potential sources of interference, such as transformers, motors, and fluorescent lights. Use shielded cables and filters to minimize the impact of EMI on the grounding system. If the potential difference persists after performing these troubleshooting steps, it may be necessary to consult with a qualified electrician to conduct a more thorough investigation. The electrician may use specialized equipment, such as a ground impedance tester, to identify and locate the source of the problem. It's important to note that working with electrical systems can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, it's best to leave the troubleshooting and repair work to a qualified electrician. A potential difference between ground and grounded conductors is a symptom of an underlying issue in the electrical system. By following a systematic troubleshooting approach and addressing the root cause of the problem, you can ensure the safety and reliability of the electrical system. Remember that electrical systems can be complex, and it's always best to consult with a qualified electrician if you're unsure about any aspect of the troubleshooting or repair process. Electrical safety is paramount, and it's essential to take all necessary precautions to protect yourself and others from electrical hazards. When dealing with electrical systems, always ensure that the power is turned off at source before beginning any troubleshooting or repair work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses, to minimize the risk of electrical shock or arc flash. Follow all applicable electrical codes and regulations to ensure that the work is performed safely and correctly. Consider the potential causes meticulously, focusing on connection quality, ground pass, and external interference. Remember, a systematic approach is the key to successful electrical troubleshooting.